Good morning, everyone. Today we're going to continue looking at linear programming models. What we've done so far and what we're going to continue to do is show the versatility of linear programming. What we see is that if we are able to take a problem and convert the natural language into our linear programming format, we have a very good chance of solving that problem. And what do we mean by solving the problem? What we mean is that we are able to determine optimal solutions. With linear programming, our goal is to determine what is the best choice by removing opinion and bias from the decision-making process. And what we are going to do today is continue on with that process. Now, when we first modeled this in kind of a real-life example, we looked at a dietary situation. Given dietary requirements, given the nutrients in different items, and given the cost of those items, we were able to successfully optimize our diet, while also minimizing the cost to optimize that diet. In our second example that we worked on last class, we looked at an investment example. And what that did, 2 classes ago, but also that we reviewed yesterday, is we were able to determine, given return on investment, given the limitations placed on us, we were able to determine the optimum way to invest our money while also maximizing our returns. Now, what we're going to do today is we're going to look at 2 more examples. The first one, as you can see in front of you, is a marketing example. Once again, we see the versatility of linear programming. If we're able to put things in the correct format, linear programming allows us to solve these problems relatively easily once we've gotten them in that format and entered the data correctly. So let's begin. This is a marketing example. The Biggs department store has hired an advertising firm to determine the types and amount of advertising it should invest in for its stores. Not very important yet. The 3 types of advertising available are television, radio, and newspaper ads. These represent decision variables. So let's highlight those. And we'll say that X1 is television commercials. X2 is radio ads. And X3 is newspaper ads. And what this represents is X1 and X2 and X3 represent our decision variables. So the retail chain store up here desires to know the number of each type of advertisements it should purchase in order to maximize exposure. So we'll highlight this because this tells us that we're trying to max Z, where Z is exposure. It is estimated that each ad or commercial will reach the following audience and cost the following amount. So this information here gives us a lot of important information that we'll draw on later. The company, though, has some restrictions. This is a key word because it tells us that these are the constraints governing our situation. These are the rules that guide how we can invest. So number one, they should limit the total budget to $100,000. Let's highlight that information. The television station only has time available for 4 commercials. Another key point. The radio station only has time available for 10 commercials. Also critically important. The newspaper station has space for 7 ads. Color. And the advertising agency only has time available to produce 15 commercials or advertisements. So we can see here 1, 2, 3, 4, 5. We have 5 constraints governing our behavior. So now that we have all of the key information highlighted, we'll reduce this just to keep it all on the same page. Now that we have all of the key information highlighted, we can begin to format this into the critically important linear programming format. So the first thing we need to do with the linear programming format is enter our objective function. So in this situation, what are we trying to maximize? We're trying to maximize exposure. So we write up here, maximize Z, knowing that Z is exposure, equal to 20,000 x1. That comes from this number right here. This is the exposure we will get times the number of television commercials we have, x1. So 20,000 x1 plus 12,000 x2 plus 9,000 x3. These numbers are found here in terms of exposure. This information was given to us. In our investment situation, this was return on investment rates. In our dietary situation, this was the cost of different food. But in this situation, we're not trying to do that. We're trying to maximize exposure. And it is exposure per television commercial, x1, per radio commercial, x2, per newspaper ad, x3. So here we've completed successfully our objective function. The next step is we have to go to constraints. The first one, C1. Now C1 in this situation, we know is the total amount available for advertisement is 100,000, and that we see right here. They should limit the total budget to 100,000. So now we're going to multiply our cost per advertising type, and it must be less than 100. So we have 15,000 x1 plus 6,000 x2 plus 4,000 x3. And this must be less than or equal to our total available budget of 100,000. That's our first constraint. Now the second constraint, we have to figure out the television station only has time available for 4 commercials. So C2, television station, so that's television commercials. So the total number of commercials, X1, must be less than or equal to what we have available, which is 4. Our next constraint, going down the list, we see that the radio station is X2, must be less than or equal to 10. And we get that from right here. The radio station only has time available for 10 commercials. Go into C4, and this says that X3 must be less than or equal to, quite simply, 7. We see that right here. The newspaper only has space for 7 ads. If X3 is more than 7, it means that we have advertised in the newspaper more than 7 times, and that is impossible given these constraints. And the final constraint, C5, shows that X1, which is the total number of television, plus X2, the total number of radio, plus X3, the total number of newspapers, must be less than or equal to 15. And we get that from the third sentence. The advertising agency can only produce 15 commercials or advertisements. More than that is impossible. They don't have time. So what we've found here is our objective functions and the constraints governing our behavior. This is essentially what we've found so far. We've looked at a very basic, very common situation. A business wants to advertise. This is what we estimate they'll reach. This is what it will cost. We also looked at very common limitations. You have an advertising budget, say 100,000. Television does not have unlimited space. Radio doesn't have unlimited space. And newspapers don't have unlimited space. And then we threw in one final situation that is again very common, because not everybody has an unlimited budget, and if you don't have an unlimited budget, the advertising agency cannot work for you in an unlimited capacity. So they can only produce 15 commercials and 15 advertisements. We've taken a very common natural language situation, highlighted the key points, and translated those key points down here into an objective function, maximizing exposure, given 3 different choices. And we've governed our choices based on very real world, natural situations like limited space for advertising, a limited advertising budget, or limited time available from our advertising agency. Thank you very much, everyone. This is the end of section 1. We've correctly formatted the problem. What we're going to do in section 2 is first we're going to look at QM. We're going to solve this because we have the equations ready. We're going to see that once we have the equations ready, it's a relatively easy solution. And then, continuing on in section 2, we're then going to move into Excel and solve the same problem again, showing you again how easy it is once the equations have been put together, how to solve these problems. Thank you very much, everyone. See you momentarily in section 2. Hello, everyone. In this second section, we're going to do two things. First, we're going to go through QM, and I'm going to do the marketing example. The reason we're doing QM first is because at this level of difficulty, it still remains largely a much easier program to use. It won't always be that way. There will be situations later where it doesn't work well and we have to go to Excel. For that reason, we're all going to continue using Excel, but for now, we can focus, at least temporarily, on QM initially so that we can check our answers later when we go into the slightly more difficult to use Microsoft Excel with the solver add-on. As we saw last class, our last section, we're going to do a very simple marketing example. This example is exceptionally simple, but the basic idea remains the same. First, we have to read the question carefully. We have to highlight the key points. We don't have to highlight them, but it does help us when we're formulating the equations later. After we read the question carefully, we want to look at the relevant data and we want to compose, in this situation, our A, objective functions, and B, constraints governing our actions. Okay, so first and foremost, we read carefully, we formulate our objective function, and then when that is complete, we go in and we look carefully one more time before putting together our constraints. So let's begin to do that now. We've already done that in our previous example. So what I'm going to do now is, with QM, as always, we click on Module, we go down to Linear Programming, and we start a new file. Let's call this a marketing example. Then we have to enter how many decision variables and how many constraints that we have. In this situation, and you'll remember from last time, we have 3 decision variables: television commercials, radio commercials, and newspaper ads. So we have 3 decision variables. We also know in this situation we have not 1, 2, 3, or 4, but 5 constraints. So we enter that information here. We hit OK, and the computer will generate this chart for us. So first, we'll expand some of these columns. Now, as we mentioned, we'll expand these ones too. Why not? The first one, our first decision variable, as I mentioned, is television ads. Our second, radio ads. And our third is newspaper ads. Now, what we're trying to maximize in this situation, if we refer to the question, is quite simply exposure. So that's what we enter here. This line represents, or this row represents our objective function. That's what we're entering here. So if we have television ads, we reach 20,000 people. If we have a radio ad, we reach 12,000 people. And if we have a newspaper ad, 9,000 people. These represent our exposure situations depending on which of the three decision variables we choose. We're trying to maximize exposure through any combination of these three advertisements. That is what this problem is designed to do. Given our costs, given our limitations, we are essentially trying to determine how we can maximize the number of people that see our advertisements. So our first constraint, and that was cost, a budget. We have a limited budget. Like many real-world situations, our budget is not unlimited, and that's what we're showing here. So in our budget, we know television ads cost $15,000. We know radio ads cost $6,000. And newspaper ads cost $4,000. And the total sum of these advertisements must be less than or equal to $100,000. Our budget is $100,000. We cannot spend more than that. So whatever combination of the above advertisements we choose, the total cost must be less than $100,000. That's what we've indicated here. Now, our second constraint we'll label available TV space, because our TV stations that we can advertise with do not have an unlimited number of spaces available for our advertisements. So we have to go in and we have to maximally, we can only have 4 advertisements. How do we indicate that? So it's television ads must be less than or equal to 4. So we put the number 1 here. And it must be less than or equal to 4. What that means is if our television ads, if the number here exceeds 4, it's not a viable solution. It's not a possible solution, because we're in a scenario where we have only 4 available. 4 is okay. 3, 2, 1, no problem. Any more than 4, and this doesn't work. That's what we've told the computer. The computer can try as many combinations of television, radio, and newspaper that it wants. But if the number of television exceeds 4, that's not a viable solution. Constraint number 3, we know that we're limited to 10 radio commercials. So available radio space. We indicate that again by putting the number 1 here, less than or equal to 10. Again, any combination of advertisements where radio is less than 10 is a viable solution. Any combination where radio is more than 10 is not a viable solution. That's what we've indicated here. Constraint number 4 is that newspaper ads are, for simplicity's sake, let's say available newspaper space. We know in this situation, the number of newspaper ads must be less than or equal to 7. So what we've shown in these first 3 is that as long as television is less than 4, radio is less than 10 and newspaper is less than 7, these are viable choices. Whatever maximizes exposure while still being less than those three and under 100,000 total costs is a possible solution. We have one more constraint. That's total advertisements. And here we know the total, the advertising agency only has enough space for 15 total advertisements. So we indicate that by going 1, 1, 1, less than or equal to 15. If our total advertised television plus radio plus newspaper is more than 15, it doesn't work. That's what we've shown here. So to recap, we want to maximize exposure, but we're limited by 5 different things. Number one, we want to maximize exposure, but we have to stay under $100,000 total. We want to maximize exposure, but we cannot do more than 4 television ads. We want to maximize exposure, but we cannot do more than 10 radio ads. We want to maximize exposure, but we cannot do more than 7 newspaper ads. And altogether, between the 3 decision variables or the 3 advertising outlets, we cannot be more than 15 total advertisements. That's essentially what we've done. And if you remember from the last section, it seems very clear that radio and newspaper are superior to television, because radio is more than half of the exposure of television, but only slightly more than 1/3 the cost. Clearly, if it's me and I'm making a biased or opinion-based opinion, I will quite simply say, you know what? I'm going to choose all radio. But we also have newspaper, which is also better than television. It's slightly under half the exposure, but less than 1/3 of the cost. That's also better than television. But is it better than radio? It's 3/4 the exposure of radio, but only 66% of the cost. So maybe that's superior. As we add additional decision variables into this process, it becomes increasingly difficult to make correct choices based on opinion alone. It becomes almost impossible to do it based on opinion alone. That's why we use linear programming, and that's why we use QM or Excel, because they're telling us the best possible choice. If we enter the data correctly, the computer program will solve, and it will tell us what our best choice is. So let's hit the solve button here, and we see now we've got a viable solution. We have 1.82, 10, 3.18, 185,000. What that tells us is our ideal situation is, as we said, radio is pretty good. We want to do the full 10 radio commercials. Newspaper, we want to do 3.18 commercials. And television, 1.82. Now, we'll talk about the impossibility of 1.82 commercials in the next chapter. But for now, what's important is understanding that we have solved this question perfectly. These are the best possible choices we can make. If we deviate from these choices in any way, A, we'll violate one of our restrictions, or B, we'll reach less people. If we follow this system, we will reach 185,000 people with our advertising budget. That is our best possible situation. Thank you, everyone. We'll be back in just a minute with the Excel version or the Excel solution. Hello, everyone, and welcome to the third section of this group. What we're going to do here, although we've already solved it in QM, is we're going to solve this problem one more time in Excel, just because it is a little bit more challenging, and I'd like you to be clear on how to do that. So as always, the first step is naming it. Let's call this one the marketing example. Now, as before, what do we enter here? Very simply, our choices. So in this situation, advertisements. But let's make everything a little bit bigger, just for simplicity's sake. And our first advertisement is television ads. Our second, radio ads. And our third, newspaper ads. Now again, this isn't important, but we're going to label it here as exposure. The reason being, that's what we're trying to maximize. It's important to remember this column here essentially acts as our objective function. So here we have 20,000, 12,000, and 9,000. Next, after we move down, we're going to look at our resources, or limitations, constraints as well in this situation. So our first limitation, how do we phrase this? We're going to call it budget. Our second, as we saw before, TV space. We'll keep it easy. Radio space, newspaper space, and finally, total ads. Now, up here, as before, we'll call it usage, constraints, and available. These are things that we've done time and time again. It should be very clear to you right now, but the basic idea is we're entering our limitations here. And we saw from before, the first one, our budget, is the number of, or the amount, or the price we pay for television ads, which is $15,000, plus the price we pay for radio ads, $6,000, plus the price we pay for newspaper ads, $4,000, must be less than or equal to 100,000. That's all we've done here. TV space, we saw before. TV space is that television ads must be less than or equal to 4. Radio ads, and we can make this 0. Why not? It doesn't really matter. And we saw again, the number of radio space must be less than or equal to 10. Newspaper must be less than or equal to 7. These are things that we entered already in QM, but we're doing them here. The only difference is we create our own graph, whereas in QM it was provided for us. This set here, one more, we'll do one more first, and that's total ads must be less than or equal to 15. So this board that we've essentially created here is exactly the same board that we saw earlier in QM. We've just created it fresh here. And this, in the future, is one of the benefits of our situation, because we can essentially alter the board how we want with Excel. With QM, we're always limited to the same situation. That's why as we get progressively more difficult, it does occasionally become easier to use Excel. So let's move down here. We haven't entered any formula yet, but here we're going to relist our advertisements, because this is where the computer is going to run permutations. This is our situation where the computer will check if we've reached our goal or not. So the first one, TV, radio, newspaper. And as before, we're trying to maximize our exposure. So we've set everything up here, but we're missing one step. And the difference between Excel and QM at this level is that the next step, the actual equations that dictate usage and profit, are built automatically into QM. Whereas in Excel, we have to add them ourselves. So let's start with profit. Now, exposure. Very simply, exposure is the amount of TV ads we buy times the amount of commercials we have, times the exposure per commercial. The exposure for radio is the amount of radio ads we buy times the exposure for one commercial on radio. And the last one, newspaper, is the amount of exposure times the amount of ads that we buy. So let's do that here. So we have exposure, 20,000, times number of ads, plus exposure, 12,000, times number of ads, plus exposure, 9,000, times number of ads. Right now will be 0 because we haven't purchased any ads. Usage is budget for TV times TV commercials, plus budget for radio times number of radio ads, plus budget for newspaper times newspaper ads. All ads are 0. This will be 0 right now. We repeat that four more times. And I'll do that right now. Please bear with me. Now we've completed all our equations. Essentially where we are right now is in QM, we would be at the stage where we would hit solve. And the reason QM can solve very quickly is it is software designed exclusively for managerial science. Excel, on the other hand, has a massive amount of functions. One of them, with the solver, is managerial science. So we click on data and we go over to the solver. First one, our objective is to maximize exposure. The equation for that is listed in cell B16. We're trying to maximize. The variable cells is where the computer will alter the numbers. It is where the computer will experiment with different numbers until it reaches our ideal solution. So changing variable cells, B12, B13, 14, and 15 in this situation. Simplex LP. Oh. Now, we have to add our constraints. We look here and we see that all constraints are less than or equal to. Because all are less than or equal to, we can take a shortcut here, something we haven't done before. But let's try that shortcut. Cell reference E6 to E10. Because they're all the same, we don't have to enter them individually. All of those E6, E7, E8, E9, E10 must be less than or equal to G7, G6, 7, 8, 9, and 10. We've now compressed all of our constraints into these two ideas. We hit OK, and instead of 5 different constraints, we have 1. Both are totally acceptable. If you're more comfortable doing it the other way, that's totally okay. If you'd like to do it this way, to save a little time, if all of the constraints are less than or equal to, if they're all greater than or equal to, this works. So here we've entered all of the relevant data. Everything is entered correctly, assuming we hit solve. Solver found a solution. All constraints and optimality conditions are satisfied. Meaning a solution was found, every constraint was obeyed, and we have an answer. We hit OK, and we check. It's 1.82 television ads, 10 radio ads, 3.18 newspaper ads. These are exactly the same numbers we received in QM. If we proceed like this, we will reach the absolute maximum amount of people, 185,000 people. If we do any other possibility, if we choose any other, we buy 3 TV and less radio, we either exceed our budget, we exceed the limitations given to us in terms of TV, radio, newspaper, or total ads, or we actually reach less people. That's what we've shown here. This is our best possible scenario. Hopefully there are no questions. I'm going to continue on to one new type of problem in the next section, or in the next unit. Thank you very much, everyone, for listening. Hopefully everything is clear to you now. Thank you again.